In 4.1.3, we started to look at what happens if the angle changes. So let's continue with 4-24 using the software for slope ratios and this slider here. Let's see if I can get this slider to work with. Yes, I can with the stylus. Okay, so the first question we were asked in this section was to start with a 45-degree angle and picture what would happen as you open up this slope angle here at 45. Well, as I open up this slope angle and make it greater than 45, what changes? Does dy change or does dx change, the difference in y or the difference in x? There we go. As it gets to 48, the blue line is getting longer, so that's the difference in y. As I open up the angle, it gets longer, the change in y gets longer and longer and longer. The ratio of change in y divided by change in x gets longer and longer and longer. Could I even make change of x smaller and smaller and smaller? And bring this back down to a 45-degree angle. Where my ratio is a 1-to-1 ratio. There we go. So in example 4-24b, we have a triangle that looks like this. We have an unknown angle given by the variable theta with a slope ratio of 50/6. Well, that's a pretty steep slope ratio, so angle theta must be pretty large. Check your trig table. Do we have an angle with ratio 50/6 that we can refer to? Or will we need to use the dynamics software? So 50 divided by 6 is 8.33. I remember something about 8.33. So let's take a look. As I raise the angle greater than 45, I'm going to look for a slope ratio around 8.33. If I can get the stylus to move. There we go, 8.33. So keep going, keep going, keep going. Here we go. Well, at 83 degrees, I have a slope ratio of 8.14. Can I get a little larger than that? At 84 degrees, I have a slope ratio of 9.51. So somewhere between 83 degrees and 84 degrees is the ratio I'm looking for. So I'm going to list that as between 83 and 84. Theta is less than 84 and greater than 83 degrees. And I think it's closer to 83. So approximately 83 degrees. Remember, we are approximating in this unit. 4-24d shows us this triangle. And you're whipping up these triangles every time you see one. You're getting better and better at drawing them. Now we knew that at 11 degrees there was a 1-to-5 slope ratio. So I believe that at 8 degrees, what's going to happen to that ratio? Well, let's take a look. Slope ratios, I just need to slide this down until my ratio here, or no, until my angle here shows 8 degrees. So down, 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 down. to 8. So 0.68 over 4.82 is my change in y by change in x. So the slope ratio for an 8-degree angle is 0.68 or 68 hundredths over 4 and 82 hundredths. Here's my change in y. Here's my change in x. So 20 is to x as 0.68 is to 4.82. Let's multiply by both denominators on each side. Allows me to reduce this denominator to 1, and I'm left with these factors, and allows me to reduce this denominator to 1, and I'm left with these factors. You're pushing the buttons on your calculator. Please don't sit without a calculator. Please find a calculator and push the buttons. X is approximately 141 and 76 hundredths. E is interesting. We're given this triangle for E. We have an unknown slope angle, theta, with a side length of 0 and 14. Now, one of the possibilities here in the directions, if a triangle's indicated measurement is not possible, explain why. Well, the only way for this triangle to exist with 0 in the change in y side is if the hypotenuse lies right on the side with length 14. That would not be a triangle. Theta would have to be 0. So continue to work with this software. To find slope ratios and to complete 4-24. And also use the software to complete the trig table toolkit. You have an 8-degree angle, an 18-degree angle, 70, 72, 83, 84, and 89 to fill in. So we will start tomorrow's class with the trig table toolkit on your desks. Be as accurate as you can filling this out.